Seventh chapter, finding initial basic feasible solution. So in this topic, there are three methods are there. First method, northwest corner rule. So initial basic feasible solution, three methods are there. First method, northwest corner rule. The second method, matrix minima or lowest cost method. So third method is Vogel's approximation method. So three methods. So first method is nothing, northwest corner rule. So in this method, allocations are made starting from northwest. So upper left so northwest in the table, the allocations are starts from northwest. Upper left, so corner of the transportation table. So completely the transportation cost in this cell we assign x11. So it's nothing but top of the table. So northwest corner x11 is equals to minimum of a1 comma b1. If a1 is less than or is equals to b1, then x1 is equals to x11 is equals to a1, and entire product is available for the transportation at origin is 1. So this means so xij equals to 0 for j is equals to 1, 2, 3 up to n, and the first row is eliminated for the allocation. So here so x11. So first table corner, northwest corner. So x1 is nothing but first position. In this first position, so we can allocate minimum of a comma b. So in this a comma b, so row wise and column wise, so we can allocate minimum of a comma b in first cell. the domain a destination 1 is less than, then reduce it to b minus a. So bi minus ai. So we assign x21 is equals to minimum of a2 comma bi minus a1 and proceed as before. So if in case a1 is greater than b1, then x11 is equals to b1 and the domain from destination is 1 is fully, hence the first column can be eliminated. For from further consideration, so xn is equals to 0 for I is equals to 1 to m. So now we assign x12 is equals to minimum of a1 minus b1 comma b2 and proceed as before. So for example number 7.4.1, obtain initial basic feasible solution to the following transportation table by using northwest corner rule or northwest corner method, and also compute cost of the transportation. Okay. So this is given table. So these are the requirements. O1, O2, O3 are the requirements, and D1, D2, D3, and D4 are the availabilities. So here the total number of requirements is equals to the total number of availabilities. So availabilities is equals to requirement. So this is called balanced transportation table. So balanced transportation problem. So requirements is equals to availabilities. So the total requirements is nothing but 34 and availability is also 34. The requirements is equals to availabilities. So this is balanced transportation problem. So this is balanced transportation problem. So step 1 starts from northwest is nothing but northwest is nothing but top of the table. Here 19 in this table. So 19 is the northwest, that is upper left corner of the table. So 19 is the northwest corner, upper left corner of the table, comma x11. So corresponding to, so here this is the, so this is northwest corner. So in this northwest corner, so row wise is 7 is the availability. So column wise is 5 is the requirement. So x11. So x11 is equals to minimum of 5 comma 7 to 5 comma 7. So row wise 5, row wise 7, column wise 5. So in this minimum is nothing but 5 is minimum. So allocate 19 into 5. So 19 into 5, here 5 minus 5 is 0. So 19 allocated by 5. So requirement 5 minus 5 is equal 0. So cross out entire column, and row requirement, column requirement is 2. Here allocation is 5. So 19 top of the corner allocated by 5, and remaining table here availability is 2 because here 5's allocation is there. So remaining 2. So remaining table here also. So remaining table in this table. So this is northwest corner. So top of the table. So D2 30. So here, so minimum of 2 comma 8. We can take row wise and we can see row wise and column wise. So row wise is 2 and column wise is 8. So minimum of 2 comma 8. So minimum of 2 comma 8 is nothing but, so 2 is minimum. So 2 allocation. So here 30 is allocated by 2. So 30 is allocated by 2 and here 8 minus 2. 2 is allocation is there. So remaining 8 minus 2 is 60. So cross out entire row. So 2 minus 2, 0. Row requirement is 0. So 2 minus 2 is 0. So cross out entire row and column. So first row is cancel and second row. So second row also. So here allocation is 2. Here allocation is 5. So here only 6. So remaining table. So this is the northwest corner. 30 is the northwest corner of remaining table. So here also minimum of 6 comma 9. So row wise 9, column wise 6. So minimum of 6 comma 9. So 30 is allocated by 6. So 30 is allocated by 6 and so column requirement is 0. So cross out entire column. So column requirement is 0. Cross out entire column. So remaining table. So this is the remaining table 40, 60, 70, 20. So here 3 is there. So 3 is there. So remaining table 40, 60, 70, 20. So in this table, so north corner is nothing but 40. Northwest corner is 40. So here allocated by so 7 or 3. So minimum of 7 or 3, minimum is 3. So here allocated by 30s, 40s allocated by 3. So cross out entire row because row requirement is 0. So 3 minus 3 equals to 0. So here 7 minus 3, 4. So final table 70, 20. So this is the final table 70, 20. There 4 is there. So directly we can allocate 70 into 4, 20 into 40. So that is equals to 18. So availability is equals to requirements. So we can see step 1 x11. So corresponding to the cell O1 comma D1, here availability is 7 units and demand is 5 units. Hence assign x11. So top of the table x11 is equals to 7 comma 5. So minimum of row wise and column wise. So 5 comma 7. So minimum is 5 in the cell O1 comma D1. So this completes the demand D1 and you can ignore column 1 for further consideration. So that is nothing but we can cross out entire column because column requirement is 0. Because column requirement is 0. So next step, move horizontally to O1 D2. So this is next horizontally 30. O1 D2 horizontally 30. Since there is a left corner of 2 units available for A1 and the demand at D2 is 8 units. So assign X12. So X12 is equals to minimum of A1 minus B1 comma B2. So that is equals to minimum of 2 comma 8. Here in place of 7, 2 is there. So minimum of 2 comma 8. So minimum is 2. So allocate O1 comma D2 since supplies O1. So here minimum is nothing but O1 comma D2 30 allocation minimum of 2 comma 8. Here minimum is 2. So we can allocate 30 by 2. Allocate 30 by 2 and further consideration. So we can cross out entire row. So we can cross out entire row because the row requirement is 0. Since the demand of 6 units at D2 and there are 9 availabilities units at O2. So next table, similarly 70, 30, 40, 60, 8, 70, 20. So we can proceed similarly 39 comma 6. So here 6 is there. So 9 comma 6. So we can allocate minimum of 9 comma 6. So 6. So you can ignore column 2 for consideration. The next last step. Now move to cell O2 comma D3 to allocate 3 units to left at O2. Since minimum of 3 comma 7 is equals to 3, the remaining demand of 4 units at D3 is now meets from O3, and you can ignore D3 column. So next we can ignore D3 column because the column requirement is 0. So there is a demand of 14 units at D4. There is a leftover availability 14 units O3. So allocate X34 is equals to 14 and stop. The initial basic feasible solution to the transportation table now obtained by like this. So after all allocations, so here 19 is allocated by 5, 30 is allocated by 2, so 30 is allocated by 6, and 40 is allocated by 3, so 70 is allocated by 4, 20 allocated by 14. So these are the all allocations by northwest corner rule. Okay. So this is another method is nothing but stepping stone method like this. Stepping stone method. So this is northwest corner rule. So the initial basic feasible solution the total transportation cost is nothing but 19 into 5 first cell plus second cell 30 into 2 plus 30 into 6 plus 40 into 3 plus 70 into 4 plus 14 into 20. So this is the total transportation cost. The total transportation cost equals to 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20. So these are the all allocations, the number of allocations. So therefore, the total transportation cost is 1015 rupees by using northwest corner rule. So this is the first method, northwest corner rule. Another method, another name is stepping stone method. The second method is matrix minima or lowest cost entry method. In this method, we look for the row and column for each Cij. So Cij is nothing but cost of matrix. So these all are the Cijs. So is minimum in the given table, there is a tie, 2 or more minimum cost. If they select to if there is a tie, 2 or more minimum cost, then select the lower number row. If they are appear in the same row, choose the lower number row numbered column. Since the logic in this method to move the maximum possibilities commodity, the least cost chosen corresponding Xij as such as possible subject to the availability, the requirement constraints in the ith row and jth column. After dropping a row or a column, repeat this process with the reduced transportation cost matrix until the total availability at origins is the different requirement destination. So this is method is nothing but so same matrix minima or lowest cost entry method. Same example. So in this, so this is cost matrix. In this cost matrix, so least element. So least element is nothing but least cost. So question is nothing but question. Find the initial basic feasible solution. Find the initial basic feasible solution to the following transportation problem by matrix minimum method and compute the cost of the transportation. Is given cost matrix. So this is cost matrix. So in this availability required, first we have to verify the given transportation problem is balanced or unbalanced. So this is balanced transportation problem. So how to verify the balanced or unbalanced transportation problem? So we can count number of requirements 5 plus 8 plus 7 plus 14, 34. And also availabilities 7 plus 9 plus 18 equals to 34. Requirements equals to availabilities. So therefore, the given transportation problem is balanced transportation problem. So by using least cost entry method, in this all cost, so we can choose least cost. So 19, 30, 50, 10, 70, 30, 40, 60, 48, 70, 20. In this all elements, so which is the least element? 8 is the least. So here 8 is the least. So this is least. O3D2. So O3D2 is the minimum. So minimum unit cost. So here we can allocate row wise 18 is there, column wise 8 is there. So O3D3 minimum of row wise 18, column wise 8. So minimum of 8 comma 18. So minimum of 8 comma 18. So minimum is 8. So we can allocate 8 at O3 comma D2. So here allocate 8. So cross out entire column. So because requirement is 0, 8 minus 8 0 and availability is 10. 18 minus 8 equals to 10. So availability is 10 and requirement is 0. So we can cross out entire column. So second column. So that is the matrix shows that the cell O3 comma D2 has the minimum unit cost. So it's nothing but least cost. Entire table least cost is 8. That is C32 is equals to 8. Allot 8 units to X32 and ignore this column for because requirement is completely satisfied. Is nothing but the column requirement is 0. We can allocate 8. 8 minus 8 is always 0. So here 18 minus 8 is nothing but availability is 10 is there. Consider the reduced matrix for availability 10 in the third row. So here 10 in the third row because 8 is there. 8 is allocation is completed. So remaining 18 minus 8 is 10. The minimum unit cost in the reduced matrix is C14 is equals to 10. So here entire column is eliminated. So remaining cost matrix. So remaining cost matrix. So which is the least cost 19, 50, 10, 70, 40, 60, 40, 70, 20. In this all cost 10 is the least cost. Okay. So 10 is the least cost. The minimum unit cost. So reduced matrix is C14. So C14 is equal to 10. So next least element in the table, next least element is 10. allot 7 available units here. Strike, ignore the row. So here at this place 10. So row wise 7 is there, column wise 14 is there. So row wise 7, column wise 14. So allocate minimum of 7 comma 14. Allocate minimum of 7 comma 14. So minimum is 7 allocated by, so 10 is allocated by 7. So O1 D4 is allocated by 7. So that is, so 10. So 7 is available units here. So ignore entire row because, so here 7 is allocation. So we can cross out entire row and column because the column requirement is 0 and row requirement is 0. So D2 is cancelled or D2 is ignored and O3 also ignored. Further, the matrix requirement D4 is now 7 units. The lowest cost matrix is 20. After cross out row and column, so next remaining elements 70, 40, 40, 70, 60, 20. In these 6 elements, so least cost is 20. So 20 is the least. So here minimum of row requirement and column requirement. So remaining the lowest cost matrix is 20. Here you can allocate all the 7 units for fulfill the requirement. So you can ignore this column. So here 7 is there. 7 and here 18 is there. So minimum of 7 comma 18. So minimum is 7. So allocate in place of 27. Allocation is 7. So we can cross out entire column because the column requirement is 0. So we can cross out entire column because the column requirement is 0. So 7 minus 7 is 0 and 18 minus 7. So row requirement is, remaining row requirement is 11. So these are the crossword columns and rows. So next, so remaining elements are 70, 40, 40, 70, 2 by 2 matrix. So here least cost is nothing but 40 is the least cost, but the 2 positions are there, O2 comma D3 and O3 comma D1. So we can choose any one. So here, so C23 comma C31 is equals to 40. Now choose 2, 3 and allocate 7 units to require. So you can ignore third column. So we can choose any one because here 40 and 40 is there. 40, 40 is there. So you can choose any one and allocate minimum row wise and column wise. So minimum and cross out entire row or column. So proceed. So allocate 7 units to require. So you can ignore third column. So now finally allocate 3 units to, so now allocate 3 units to O3 in the cell 3 comma 1. So x13 is equals to 3 and lastly the 2 units to the cell 2 comma 1. So that x12 is equals to 2. Now we shall summarize the allocations made above shown in the table. So here allocations. So 70 is allocated by 2, 40 is allocated by 3, 8 is allocated by 8, so 40 is allocated by 7, so 10 is allocated by 7, and 20 is allocated by 7. So these are the all allocations. So therefore, hence the total transportation cost is equals to 2 into 70 plus 3 into 40, 8 into 8 plus 7 into 40 plus 7 into 10 plus 7 into 20. So the total transportation cost of the lowest cost entry method is, or matrix minimum method is 814. So previous method, so we can compare first method northwest corner method. So in this northwest corner method, So total transportation cost 1015 rupees. So but here matrix minimum or lowest cost method, the total transportation cost is 814 rupees. So comparing these two methods, so lowest cost entry method or matrix minimum method is better than northwest corner rule. Okay? So because the transportation cost is minimum, the transportation cost is minimum, the company the transportation cost is minimum compared to northwest corner rule, so he will get profit. The transportation cost is minimum, he will get definitely profit. So next method, third method, WAM method. So Vogel's approximation method. So Vogel's approximation method. This method is also known as penalty method. So allocations is made in this method on the basis of penalty cost that have been increased if allocation is missed at certain cells having minimum transportation cost. We then try to minimize in penalties. So in this method, we have to find out penalties for each row and column. So here also same question is there. In this method, we have to find out row wise penalties and column wise penalties. So each and every row penalty and each and every column penalties. So penalty is nothing but, so first row, in first row, so penalty, first row, these all are the cost. In this first row, first least element, the first least element is 1. The first least element is 1 and the second least element, the second least element is 8. Second least element is 8. The first least element is 1 and the second least element is 9. So penalty is nothing but, so second least element minus first least element. 9 minus 1 equals to 8. So first row penalty is 8. So similarly, the second row. So second row least element is 1 and the second least element is 12. So 12 minus 1 equals to 11. So penalty for second row is 11 and third row. So third row least element is 1 and so second least element is 13. So 14. So 14 minus 1 equals to 13. So these are the all penalties for rows. And here column wise also. So column wise, 1 is the least and second least element is 14. So 14 minus 1, so 13 is penalty. So second column least element is 9 and second least element is 12. So 12 minus 9 equals to 3. So next to third column, in third column, so first least element is 1 and second least element is 13. So 13 minus 1 equals to 12. And the fourth column, so in fourth column also, first least element is 20 and second least element is 23. So 23 minus 23. So next to D5, fifth column, in fifth column, first least element is 1 and the second least element is 26. Second least element 26, so 25. Okay. So these all are the penalties. So this method is called penalty method. We'll explain in next class. Penalty method or WAM method or Vogel's approximation method. can see steps. From the given transportation table, determine the penalties for each row by subtracting the least unit cost element in that row from the next least cost element in the same row. So subtraction of first least element and second least element. Penalty. Identity the row or column with the largest penalty among the different rows and columns. So all penalties, after finding all penalties, so we can choose highest penalty. So these all are the penalties. So in this, choose highest penalty. So like 13. So 13 is two times are repeated. So but we can choose any one. So here 13 is the highest penalty. So in this highest penalty, in this column, so we can choose least element. So least element is nothing but one is the least. So one is the least. So here allocate so minimum of row wise and column wise. So minimum of 50 comma 100 like this. Okay, I will explain in next class this method. PAM method, Vogel's approximation method.